Hi, many of you think you cannot program a PLC because you don't have the physical PLC with you. That's a lie. You can actually simulate PLCs, especially the one we're talking about today, which is a Siemens PLC. You actually do not need the physical PLC in front of you or connected to a PLC on hardware before you can program. We have some simulation softwares which you can use to program a PLC, and that's what I'll teach you today. In Siemens actually in the time past usually integrates the simulation software in its software. So in the times past, when you use step 7 version 5 series, you usually have the S7 PLC simulation inside the software where you click on a specific button and it opens up something like this. So the old S7 PLC sim can simulate S7-300 and 400 series. You can use any of the version from version 5 and above. The main purpose is to test your program. So when you make a program in your PLC, you want to quickly test it, you can do the simulation. Here you see it's been highlighted. You can run the program, you can run the PLC, you can stop the PLC, you can do a memory reset. Usually the installation comes with the software, the step 7 software, and this is quite a very old one. So if you join an organization which is still using step 7, you might find this within the programming engineering interface. You cannot do a communication with this simulation from the PLC you're simulating to another PLC or to another hardware. You cannot test that. It only works via a function which we call the PLC simulation soft bus, which I will show you later. After that comes the standard S7 PLC simulation, which is now developed to target the S7-1200 series and the S7-1500 series, which we program through Simatic TIA. With this, you can also only test programming. You cannot do communication. It works with the same principle as the first one, which you can only program things that are on this PLC simulation soft bus. The installation is separate. It doesn't come with the TIA portal installation. You have to install it separately, and you have to also include a license. However, with every standard Siemens installation, you have some specific days which you can use. It comes with a trial license, usually I think 14 days or close to a month. So you can always download this from the Siemens platform and try this out with your configuration. You don't need a physical PLC. The third one, which is the most advanced, is actually an hardware emulation. So it allows you to simulate and most importantly allows you to emulate hardwares. This one works only with the S7-1500 series of PLC. So emulation is you actually want it to serve as a physical PLC. So almost everything a physical PLC can do, you can use it for it. So for example, somebody sends you a software from somewhere and you want to see how it actually performs on the PLC. You can actually use that. You can use it to test your program. You can also use it as a hardware integration. So probably you have different PLCs in a project. You can use this PLC Sim Advanced to emulate one or more of your PLCs. You also need to install this separately. You also need to include a license separately. For the standard S7 PLC Sim, the license is inclusive of the license that comes with your standard Simatic TIA portal. So when you install your TIA portal, the license that you purchase or that you use for that will work with your PLC Sim. However, for the PLC Sim Advanced, you need a separate license for that. Because with your S7 PLC Sim Advanced, you can do communication with external devices. You can do communication using different modules. You can use OPC UA, you can use TCP IP, you can use different kind of communication. So usually engineers on the field would prefer this. because usually on the field you want to test communication with different devices, or maybe you're just in your engineering desk and you want to test specific communication protocols. You can actually use the Siemens PLC SIM emulation. In this training, however, we will be talking about the one in the middle, which is the S7 PLC SIM version 20, which we would only be using to test our program in this training. The Siemens PLC SIM Advanced looks somewhat like this. You can see you can have online access to your targets using PLC simulation, which would function just like this, or you can use some communication protocols. You can instantiate one or more, and the PLC family which it functions with is your S7-1500 and also your ET 200 SP modules, which functions with your 1500 or your 1200 PLC. So once again, for the purpose of this training, we will be using only the S7 PLC SIM version 20. So how do you get these softwares? Usually from the Siemens platforms. So for the standard PLC SIM version 20 or whatever version, it comes usually on the page where you download your standard S7 basic or professional softwares. So usually this is where you download your TI Portal Step 7. This is version 20, and just below it you have the PLC SIM version 20 as well, which you can directly download from there. If you want the PLC SIM Advanced, it's also on another link. I'll add all of these links on the description below. You can check that later. And you can download the advanced version using this link. If you scroll down, you'll find the installation file link down below here. As it mentions, it comes with a standard trial license, which you can use for some specific days. I would also recommend that you download this PDF document, read it. It's just like 3 to 4 pages to understand it. The third page I have here is the advanced updates, which you can already download this and install, which includes the update, or you already install this one and then download the update to update it. So I'll add all of these links in the description below for you to see that. Now we will go into our programming, and in the last training video we did our tags configuration in our S7 1200 hardware, which we've been working on for some videos now. If you haven't seen those videos, I'll also add the link down. Please ensure to watch them. You can also subscribe so that whenever I drop these videos, you can always see them directly. So we have our hardware here, and usually in some videos before now, I downloaded this into a physical device, which I showed you. But now we want to go into simulation so that when we start programming, you can also program along, test your programs using the simulation. The first thing that we need to do here is to go into our project tree, the topmost tag that we have here, the topmost, whatever you name your project is what it will show here. I named it the tags training because that was the last thing we did. So you right click on this and then you go to properties. When you go to properties, you click on the protection. In the protection, you have to enable support simulation during block compilation. If you do not enable this, you would not be able to simulate the blocks or your project. It would not function, because usually when you program your project, when you compile your project, the protection is to the fullest if you do not enable simulation. However, when you enable this, you've reduced the protection level a little. So you enable this. So usually the advice is when you're testing your project, when you're on your engineering desk, then you can enable this for simulation. When you're done, you should disable this when you want to go to sites, because you don't want this enabled on your physical hardware. So for the purpose of this training, we enable this and then we click on OK. I can save this. We have all our configurations. We have our OB1. We have our DB, which we created, a test DB as well. And nothing else. So we've clicked on this. Now there are different ways by which you can start the simulation. There is a small icon here which says start simulation, which then opens up your version of the simulation project, or you go directly to your desktop or wherever your icon sits, and then you can open the PLC sim. But for the usually the best thing is you click on this and then it starts giving you some prompts. Starting simulation would disable all other online interfaces. So it's telling you that I will take out every other thing if you are currently connected to the PLC, and just basically OK is fine. So we click on OK, and then it will bring out some other prompts and start configuring the interfaces. Currently it's opening up the S7 PLC sim. I'll put that on the screen for you now. And it directly takes the name of your project, and that's one of the advantages of programming, of opening up this icon directly from your project. So here you can see the PGPC interface is already switched to PLC sim, right? In earlier project it was showing our Ethernet card which we used to connect. Here it's showing PLC sim. So I can just say directly at the slot, and then it will search for the PLC, and basically it says one device found. So it repeats basically everything that you do when you're sitting in front of a PLC. This is the PLC sim interface. Now this scan is done. We want to load this configuration to the PLC just like we would do if we had the physical PLC in front of us. So I'll just say load, right? And then basically, do you trust the device? Yes, we trust the device. Let's load it. Checking consistencies, it will do all the configuration all over again to see if everything is fine to be simulated, just like it would do if you're actually sitting in front of a PLC. Right here, it's also checking all other devices. It's checked the scale and switch. It's checked the ET module. It's checking everything that we've programmed in this project. All checks are done, and now we're ready to download to the device. So basically just load it to the device. So do we want to start the module? For now, we have the option to say start or no action. So I'll say no action for now, because I also want to still discuss some things. So here it's checked. There are no issues, nothing at all. We'll open our PLC sim. Now this is our PLC sim interface. And here there are quite a few things I would like you to see. In this module, because we can only do the PLC sim soft bus, which is this. So the PLC sim soft bus is like a bus. It's like a soft bus network that the PLC simulation here has created between devices. We can use that exists. This is what it has enabled for us here. However, the connection TCP/IP adapter, TCP/IP multiple adapter are not enabled, and we can use this way, this PLC SIM virtual adapter, where it would create a virtual adapter for us to actually connect to the devices, these ones that you see here. And with this, we're able to do communications like OPC UA, web server, TCP/IP, and the likes. But for the purpose of this training, this is the one that we're using here, the PLC SIM soft bus, and we can do that with this software that we have. Now, these are the libraries of devices that we can simulate, and it tells you the firmware versions that it can work with. For S7-1500 from firmware version 2.0, S7-1200, which we will be working on, from version 4.0. So we're lucky that we updated the firmware version, which we did and in our last two videos or so. So we also have the ET200SP in this particular project, which we would simulate. We also updated the firmware of that, if I remember, and some all other devices that you see here. So here we have the instance. It has created the instance. Our project is S7-1200 training PLC. It's picked up the IP address, and it's currently on the stop mode because we did not start it when we downloaded it. So I can directly click on start here, which is to run, and then you see the green light is blinking. Now it's stable because the PLC is running. Now because this PLC is running, we can go into our project and go online because the physical PLC is now running. So see, we can go online directly now with our project. Basically, we don't have any physical device sitting here. We're simulating everything directly. If we go into our main OB, our main organization block, we should be able to monitor the block. We should be able to monitor our tags as well, which was what we did in the last training. I'll show that. So we don't have any program currently sitting on this. It becomes slower. Now my PC is actually a bit slow, but it becomes slower because now we're online. We're trying to monitor something that's online. So we're basically online. You see, it shows run here. If I go to our simulation and I go to stop, so if I click on stop, yeah, the PLC goes to stop. If I go back to run, the PLC blinks, 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 just like this, and then it stays on run. So basically, we're now testing. Now, if I go to our PLC tags, which was what we did in our last training, where I showed you that you can monitor. So I'll go to show all tags. And I'll quickly like to show you something. So when you're on these tags, basically tags is you want to check. So for example, I just want to quickly monitor. I want to see what's happening to my input and output, my memory bits and the likes. So if you click on this icon, which is monitor all, it will check what's actually happening online inside the PLC. Now you see that some bits are toggling. Okay, basically let's check this, which is always true. Now this bit is green. It's true because it's named as always true. Always false is false. It's named as always false. Now don't forget that these are the PLC tag tables. These are the ones that the PLC is generating. And we got these ones from our memory bits, the M bits, the ones that we enabled when we enabled our hardware. So I wanted to show you why we enabled these guys then. We have some clocks being generated inside the PLC, which has been programmed directly in the operating system of the PLC. And usually, sometimes we use them in our programs. For example, if you want to set a device or whatever, an output to always be on, to always be true, we can use this to already set it. We don't need to reprogram that. If you want to set something to always be off, we can already use this to set it. The PLC is already doing that. We don't need to reprogram it. If we want something to switch at a clock of 10 Hertz, we already have this from the PLC. We have 10 Hertz, 5 Hertz, 2.5. Basically, they switch at different frequencies, and we can use that already. Instead of programming that by ourselves, we can use it. That's why I usually enable it. We also have all our analog input, digital input. Currently, they are all our booleans are false, false, false. Our analogs are 0, 0, 0 because we don't have anything connected to those interfaces yet. Also on our ET200SP modules, we currently don't have anything showing up there, right? So this is what we have. Now I'll go offline. We will just quickly do a small program to test our simulation. So if I go into the main organization block, I'll insert here an open contact, and I'll also insert a coil. I'll still explain all of this later. So an open contact is probably a switch. So maybe this is in your room, this is always open, so your switch is always off, right? You don't just switch on your lights, it's off. And you want to put a switch here, and you say when you click on this switch, you want your bulb to be on, right? So let us say, for example, this switch is input. So let's go to our PLC tag table. If you click on this details view below, you can already see what you have in your tag tables, right? So here we want to choose um, a digital input from our PLC. So if we pull this here, it becomes the switch in this case, right? You can also just directly type. So I'll delete this. If you know what it is, right? If you already know what it is, you can already type and then it will give you a list, right? See the list here? It will give you a list of what already has this name. So that's one of the reasons why naming is very, very, very important to me, because you name it, you know what it is. So you can already type all of this in. But to be very sure, usually I advise that you go into your tag tables or your DBs. If I also click on this DB, I can see everything inside. In this, for this contact, I want to use my PLC tag table. So I will go into my digital input and I'll put it here. So the digital input, probably I'll connect a switch there later. And now I want to enable a call, which is an output. So in this case, I want to use an output in my DB. We will explain all of this later. So digital input, I want to use it to power my digital output, which is in my DB. So it takes the DB name, in this case it's test DB dots, then it goes inside of it to pick whatever I want to do. Now again, I'll put another normally open, I'll put another coil. So I want to enable something from my DB. So let me say if I enable my input 1 from my DB, right? So I wanted to enable an output on my ET200 module. So I have a digital output in my ET200 module, digital output 1. So when I enable something in my data block, I want something to go to my output on my data block. Now for us to test analogs, I'll just use a move block. So a move block is, I just want to move a value from one place to the other just for us to test. So we use this move to move variable values, right? You cannot use bits, you cannot use normally open, normally close for analog values, right? So I just want to move data around. So let us say if I write something on my DB, on my analog DB, which is integer. So for example, temperature, I want to write some, if a value comes into my test DB analog input, I want to move it to my PLC analog output, which I have. Okay, I only have input on my PLC, so I'll go to my 8200 SP module where I have analog outputs. So I want to move an output here. I want to move a value. Possibly that's a valve, or that's a door, that's whatever. So we've done this. I'll save, I'll compile everything because we've just done our program, we've written our program, we want to compile. The PLC will check again, is everything good? We'll check, are there errors? No errors, everything is fine. Then we download, because of course we're connected to the PLC. So we'll download our project to the PLC, and it says, okay, should it overwrite everything on the PLC? Yes, just overwrite it. We're sure that everything we have is fine. So it's starting to download, and then it's done. Everything is fine. Now it's downloaded to our PLC. In this case, we're simulating, right? So we can go online again to check. Are we online? Yes, so we are inside our project now, and it shows right now we're online with our project. We can see everything here looks green, which means we're fine. However, Our inputs, our contacts do not have any data yet, so we're in the perfect state. Now we can go to our simulation, and I'll also show you some things right now. So if we go into our simulation view, here we have the scan control, scan time, all of that. We don't need all of this for now. We'll just go into our simulation view because now we want to see what we're simulating. So if we click on tags, here we can see all the tags which are inside that PLC, inside our PLC here. If you remember, we named our DB the test DB, which is this DB. We can see this, the inputs and the outputs, analog input and output. We have our analog input and output, inputs from the PLC, digital input from the PLC, which takes the peripheral addresses. We also have the digital input, digital output, analog, and all of that from our ET200 SP modules. We also have our clock bits here. So one of the first things we want to do first is to create a simulation table. We'll create a simulation table here, and then we can go to our tags and directly click on all of this. You can also choose which ones you want to see. For example, I only want to see tags from inputs, so it shows me. I also want to see input and output, it shows, and then we want to see memory tags, and then our DB tags as well. So this simulation is actually very, very good. So first, let us see if we can see our clock bits, which is our always true clock bits. We also want to see, this is our always true tag, sorry. And then we want to see maybe our bytes, our clock byte, and then maybe one of the clock bits, just to be sure that everything looks good. So I click on play. Now it's monitoring, and you can see we can directly see what's happening right inside the PLC. The clock byte is changing. We have an always true, and then we have our clock, which is switching between true and false. So we're fine, right? We're connected. Now let us go and simulate our own program. Here we have the digital input one. So here I'll just put this directly, this digital input one here. And then we also want to see this D output 1. So I'll put that D output 1. Yes. Currently both are false. We also want to move a data to our analog output 1. Analog output 1. This one. Yes. So we're still monitoring, right? Now let us see what happens inside our PLC. Well, we cannot reduce this more than this, and the only thing we can do is go into the compact mode. So if we click on this, we go into our compact mode, right, where we just see basic information, which is not what we want to do now. We need to actually go into our big mode, but I think probably I'll just put them side by side. Okay, let's do it this way. So first, I want to test this digital input. I want to enable a bit in my test DB output 1, and I have the digital input 1 here, which is this. So if I go here and I click on this, so let me enlarge this once again. Yes, so this is what I want to test, the digital input 1. It's a boolean, and I want to enable this. It's currently running. It's currently not running, sorry. Now it's running now. I think somehow I stopped it. So I want to enable this contact. So I'll click on this to see if that would happen. Now I've enabled this, and you can see directly in my program, it switches on. So it means if I go into my DB, which I will open somewhere here, I will open it and monitor by the side. Let me do some cleaning. Yes. So I want to see it on the side by side. I'll also go online with my DB. Yes. So the test DB output 1 is true, and then we can see that the test DB output 1 is true here. And we did that via our simulation. If I disable this now, this should go off and this is off. Very good. So you can already simulate your programs. We also said from our test DB, we want to enable this and ensure that our output on the PLC is on. So we have this guy here in the project. We also have it on the simulation table. So I'll enable that inside our DB test DB input 1, which is this. So if I go here, I can right click and say modify operand. So I want to modify value to 1 and then I click OK. So it goes through here, it goes through here, see? And then on the simulation table, we also have a true here, this. So the output is true. The output is true in our program, the output is true on the simulation table. Basically, you can enable you can force bits to on and off. You can also check outputs that you program inside your project. Now we want to check analog values, right? So I want to move a value from the test DB analog input 1, which is this. So I want to write a value in here. I want to modify a value. So I'll just say I want to modify 47. So I put a 47 here. It pushes this value, this move block pushes this value to the output. So on this PLCSIM, is that the same? Yes. So we also have a 47 on this output. So you see, you can test everything you want to test in your project, in your programming. You can test that using this PLC simulation. One thing that you can also do is to save. You can also save this file. You can save this configuration. So when you save this configuration, it already saves your program, your project, this simulation table. It saves it. It saves your project so that when you open this project and you click on simulation, it directly opens the simulation view. You don't have to set all of this up all over again, which is a big upgrade to what we had in the past. So this is very cool. I can also save this with the project and send it to someone else. The person can open the project and open the simulation as well, which means I can say these are all the things I simulated, check them as well. You can also simulate them, rather instead of the person resimulating everything all over again. So this is what I wanted to show you today, and I hope that you've been able to learn something. You can also have various simulation views. You can create different type of simulations. So probably you want to test only digital input in one simulation views. You want to test only analog in another simulation view. You can do different types of simulations with your project. So again, I'll drop all the links in the description. Um, you can I would advise that you subscribe to this channel. Let me get your comments if you have anything you want me to explain with this. Thank you very much.